Okay, fantastic. Welcome. Here we go. We are beginning chapter 1 of plane trigonometry, and we are beginning with section 1.1. This will change for me. There we go. So 1.1 is just angles. We're going to cover basic terminology, are the degree measure, standard position, and coterminal angles. So let's look at basic terminology. First, two distinct points determine line AB. So if we have points A and B on there, it's line AB. A line segment AB is a portion of the line in between points A and B. So a line segment actually stops. A line, label it AB, but it continues on to infinity both ways. And then, of course, a ray is a portion of line AB that starts at a point and then continues on past the second point. Okay, this is ray AB. We could also have ray BA if we started at B and continued through A and continued on past A. Okay, so that's how we would label each of these lines. An angle consists of two rays in a plane with a common end point, okay, which we call the vertex. So these are two rays. They start at one point and they shoot off two different directions. Two rays are the sides of the angle. Okay, so the angle is actually the degree measure in between those two rays. The angle's measure is generated by rotation about to the vertex. So we have a ray in its initial position, which is called the initial side, usually the positive x-axis, which we'll discuss later. But then as we rotate, and a positive angle rotates in a counterclockwise direction. So the ray in its location after the rotation is called the terminal side. So terminal meaning it's ending. Okay, so it's beginning at the initial side, ending at the terminal side. A positive angle rotates in the counterclockwise direction, and a negative angle starts at the initial side and goes clockwise and ends at the terminal. So the most common unit for measuring angles is, of course, our degree measures. A complete rotation of a ray starting at its initial and ending back at that same ray is 360 degrees, as we know in a circle. 1/360th of a complete rotation gives an angle whose measure is 1 degree. So now angles are also classified by their measures. We have an acute angle, which is an angle between 0 and 90 degrees. It doesn't equal 90, but it's greater than 0 degrees and it's less than 90 degrees. A right angle is when we actually reach 90. It's exactly 90 degrees. An obtuse angle is greater than the 90, but less than 180. And then a straight angle is 180 degrees. For an angle measuring 40 degrees, find the measure of its complement and its supplement. Okay, so complementary angles are two angles that add together and equal 90 degrees. Supplementary angles are two angles that add together to equal 180 degrees. So if we want to find the measure of its complement, then we subtract the measure of the angle from 90 degrees. So in this case, 90 minus 40. So the complement of 40 degrees is 50 degrees. Okay, to find the measure of its supplement, we subtract the measure from 180. So 180 minus 40 is 140 degrees, which is the supplement of 40 degrees. Okay, so find the measure of each marked angle. Well, here we go. Since the two angles form a right angle, and we always know if an angle, if it doesn't tell us it's 90 degrees, but it has this little box right there in the corner, then that little box determines that it is a right angle, or in other words, 90 degrees. So we know these two are complementary, so that means I can add them together and they equal 90. So first I need to solve for x. Once I solve for x, then I can compute what these angles are. So we have 6x plus 3x equals 90. Combine like terms, divide by 9, x equals 10. So in this case, this is 3 times x degrees, and so 3 times 10 would be 30 degrees, and then the bigger one up top would be 60 degrees. Find the measure of each marked angle here. Well, here's supplementary. So 4x plus 6x is 180. Okay, so we have 10x equals 180, or x equals 18. So then I plug that back into each angle degree measure. 4 times 18, 72 degrees. And the other one is 6 times 18, which is 108 degrees. Okay, so now let's take on another topic we might not have recalled or remember from before, and that is where we discuss degrees, minutes, and seconds. Okay, this is dealt with out in navigation for sure. Okay, so 1 minute is 1/60th of a degree, almost like 1 minute is 1/60th of an hour when we're telling time. When we're dealing with degrees, it is 1/60th of a degree. Okay, so it's really small. And then 1 second is 1/60th of a minute. So it's really 1/3600th of a degree. So it gets really small as we get into the seconds of a degree. Okay, and we mark minutes by 1 little apostrophe, and we mark seconds by 2 little apostrophes. So let's perform each calculation. So 51 degrees and 29 minutes plus 32 degrees and 46 minutes. So here, just like minutes into an hour, the highest we can get is 60 minutes and we start a new hour. So we count up to 59 minutes, we get to 60 minutes, and then 61 minutes is really considered 1 hour and 1 minute, right? It's going to be the same in this situation. So the most minutes I can have in a degree is 60. So when I add 51 degrees and 29 minutes plus 32 degrees and 46 minutes, I get 83 degrees and 75 minutes. Well, I don't keep that as 75 minutes because really to go to the next degree is 60 minutes. So this would be 83 degrees plus 1 degree and 15 minutes. Or in other words, 84 degrees and 15 minutes. So here, if I take 90 degrees minus 73 degrees and 12 minutes, well, I need to think of this. If I'm going to subtract that 12, then I got to think of 90 degrees as 89 degrees and 60 minutes. Those are the exact same thing because 60 minutes equals a degree. So that way it's a lot easier to subtract. So 60 minus 12 then of course is 48. And then 89 minus 73 is 16. So then we get that calculation. We have 16 degrees and 48 minutes. Excellent. So now we're going to convert back and forth. So we need to convert 74 degrees, 8 minutes, and 14 seconds to a decimal degree, to the nearest thousandth. So how do we do that? Well, 74 is going to remain. We're not going to touch that. But we need to turn the 8 minutes and 14 seconds into a decimal. So we know the minutes is 1/60th of a degree, so I'm going to take 8 and divide that by 60. And that gives me 0.1333. Okay, but then my 14 seconds is actually 1/3600th of a degree, so I'm going to take that in my calculator and divide that by 3600, and I get 0.0039. So then I add these three together, or really my decimals together. So 1.333 plus 0.0039 gives me 0.137. So then it's 70 degrees plus 0.137 gives us 74.137. Okay. Now to convert decimal degrees into minutes and seconds. So now I have 34, that's going to remain 34 degrees. But I take my 0.817 and I do the opposite now. I multiply it by 60. And when I multiply it by 60, I get a number in front of a decimal, so it's like 49.02 minutes. Well, whatever's in front of the decimal is what I'm going to keep, so that is 49 minutes. But now I'm going to turn the 0.02 into the seconds. So since I've already multiplied this by 60 once, I only need to multiply it by 60 again to 0.02 by 60 because it's already been multiplied once. So that's basically 3,600 then. So I take the 0.02, multiply it times 60, and that gives me 1.2. So then I'll just keep the 1 that's in front of the decimal here, and that'll tell me how many seconds I have. So I have 34 degrees, 49 minutes, and 1 second. And we approximate to the nearest second, so I don't keep that 0.2 there. Okay. So now, standard position of an angle. So in trigonometry, we're going to have our standard position. So an angle is in standard position if its vertex is at the origin of our xy coordinate point, our coordinate axis, and its initial side lies along the positive x-axis. Okay, so along the positive side, that's our initial side of our standard position angle. And of course, as we go positive, we start going around counterclockwise, and negative would be going clockwise. Okay, and then we have our quadrants, which we'll discuss a little more, but our quadrant, this is our first quadrant. Our second quadrant is the one we enter second as we go counterclockwise. Third quadrant is the one we enter third as we go counterclockwise, and fourth is the one we enter fourth. So trigonometry is kind of, and our angles is kind of what determines how our angles kind of, our quadrants kind of go in a counterclockwise direction. So angles, quadrantal angles. Angles that are along the x-axis or the y-axis. In other words, 90 degrees, 180 degrees, 270 degrees, goes on to 360 degrees, and so on. These are called quadrantals. Okay, so that means they are not in between in the middle. They are actually touching an x-axis or a y-axis on however many degrees we go. So then last we have coterminal angles. So a complete rotation of a ray results in an angle measuring 360 degrees. Well, by continuing that rotation, angles of measure larger than 360 can be produced. Such angles are called coterminal angles. So if my original angle is 60 degrees, well, a coterminal angle could be going around all the way 360 plus an additional 60. So a coterminal angle is 420 degrees, meaning it's ending at the same ray. So 60 degrees ends at that ray right there. We go 420 degrees, it's coterminal, okay? Ends at the, kind of shares that terminal side. Okay, 110 degrees. Well, I could go 360 plus another 110, which would be what, 470? Or I could go around another entire time, which would give me 830. So really, measures of coterminal angles differ by multiples of 360. However, I could have, and I don't believe they discuss this, maybe in the next slide, I could have a negative coterminal angle. So let's say I've got a 60 degrees here. Well, if I go negative 300 degrees, that is also coterminal with 60 degrees. So going in a negative 300 degrees is coterminal because it is ending at the same ray as well. All right, find the angle of the least positive measure coterminal with 908 degrees. Okay, well, I've got to figure out how many 360s are in there. Okay, and so then that will give me then to what's left less than 360. So I figured a 360 and 360 is 720. So I know at least two 360s go in there. So basically I can take 908, subtract 720, and I get 188 degrees. So an angle of 188 degrees is coterminal with angle 908 degrees. Find the angle of least positive measure, coterminal with angle negative 75 degrees. Okay, so here I'm going negative. I want to find the angle that's coterminal going positive. And so that could be easy. I could take 360 and subtract that 75, or in other words, add the negative 75, one or the other. That's going to give me a positive 285 degrees. So the angle of negative 75 is coterminal with angle 285 degrees. Okay, find the angle of least positive measure coterminal with the angle negative 800. Well, the least integer multiple of 360 is, of course, how many 360s can go in here? Well, we're going negative 800. So then that tells me how many times am I going to go around? Well, I know 2 times around is 720. So then I go an extra 80 degrees to get to negative 800. So that'd be negative 80. Well, I can take 360 and subtract or add that negative 80, and that gives me 280 degrees. Okay, that's the way I look at it. Here they're looking at 360 times 3 is 1080 minus 800 is 280. But if I know I subtract 720, then I'm back at the initial side. I go an extra 80 to get to the 800, and 360 minus 80 is 280 degrees. Okay, to find an expression that'll generate all angles coterminal with a given angle, add integer multiples of 360. So for example, the expression for all angles coterminal with 60 degrees is 60 degrees plus n times 360, meaning 60 plus 1 times 360, okay, gives me 420, plus 2 times 360, so I add 720 plus that would be 780, so forth and so on. So this n is kind of a, a number that we can multiply to 360. 1 times 360, 2 times 360, 3 times 360. That'll give me all my coterminal, positive coterminal angles. So in other words, value of n, as I pointed out, could be 1, 2, okay, 0. However, I could go negative as well. So if I want to go negative, this would be 60 plus negative 1 times 360. Okay, so then that would also give me then negative 300 degrees. So we could go in the negative direction by with that number n as we put it in front of our 360. All right, let's do a quick application problem and we will be done for the this lesson. So a constant angular velocity disk drive spins at a disk at a constant speed. Suppose the disk makes 480 revolutions per minute. Through how many degrees will a point on the edge of the disk move in 2 seconds? So if we are going 480 revolutions per minute, we want to know how many is in seconds. So we're going to have to split that minute into seconds. So we're going to take 480 times in 1 minute, divide it by 60 to get me in seconds. That's going to give me 8 times per second. Okay, so here it's 480 times in a minute, revolutions per minute. Okay, so but in two seconds, I want to know how fast it's spinning. So in other words, it's spinning around 8 times per. Does that make sense? Per second. So then, through how many degrees will a point on the edge of a disk move in 2 seconds? I'm sorry. So how they're describing this is not quite the same as how I would describe it, but that's fine. In 2 seconds, the disk will revolve 2 times 8, or in other words, 16 times. Each revolution is 360 degrees, so a point on the edge of the disk will revolve 16 times 360 degrees, or in other words, 5,760 degrees in 2 seconds. Okay, if that makes sense. Because we're going 480 per minute. We're going 8 times per second, or in other words, 8 revolutions per second. And so then in 2 seconds, we'll be traveling 16 revolutions. Put that in degrees. We multiply it times 360. It gives us 5,760 degrees in 2 seconds. And that wraps up our lesson for tonight. Y'all have an excellent evening.